Welcome to Pavithra Laptop Care. Today we have reserved Precision 3520 motherboard for repair. Okay, actually this is one of the advanced level services. Due to advanced level, some of the basic steps will be ignored. That is a main note to beginners. Okay, so the main problem in this motherboard is when our dealer is trying to press the power button, it's not booting up, means it's stucking at 0.20 amps or 0.15 amps. When you press the power button, 0.22 is the maximum milliamps. Okay, now what are the steps we have to do? Step by step I will explain. Before that, the main thing is you have to check the tampered parts, because it has come from the dealers, so dealers also received from other dealers, right? So that's why first we need to check the tampered part. That I may skip in this video. First I will do that part, you also do. After that, let us check from where we have to begin. Okay, from beginning one by 1 volts, because see, the main condition is 3 volts we are getting at the power button. It means here, see, this is the power button, here we are getting 3 volts. It means IO is functioning, correct? If IO is not functioning, we won't get the LDO. And at a time 3 volts LDO also we are getting. 3 volts always and 5 volts always, as per the dealer guidance. 3 volts always and 5 volts always we are receiving. So there is no issue in that. But we have to check thoroughly one by one what may be the issue in this motherboard. Okay, now first I will check the tampered part. Then I will come to the exact voltages. What are the voltages we have to check and what are the signals we have to check. Okay, first part is tampered. See, this is the board. This section is clear. See, simply first I will check and what are the part has tampered, that I will explain. See, this IO side crystal 32.768 kilohertz, and here is a new battery as put. Motherboard is very clear. The motherboard part number is LAE153P. See, almost all parts are clear. So directly I will come to the point. Just a minute. In this area he has not done anything. Okay, almost all clear. So this side, see, actually as per my suggestion, he checked the BIOS, he multiple times he did the BIOS programming, then also no result, then he brought to me. Okay, only this area, and see, main thing is we need to check nearby this supply, because sometimes burned part will be there. No indication, it's clear, so means supply is clear. So NVIDIA chipset, here also some part, it's clear. Okay, see, here one part is there, that is crystal as replaced or resoldered. The one thing is crystal is removed. See, here actually we found one BIOS here. Actually this BIOS we should not remove, because this belongs to type C. It's a 1 MB BIOS. And here one more BIOS we have, this is a 16 MB BIOS. Okay, nearby PCH we found. RTC is clear now. RAM slot, right. See, both the RAM slot are clean or not. that user will confirm. See, like this we have to confirm. Sometimes if it is loosen, it will come out, it will shake actually. By tweezer we have to do, but temporarily I am doing by screwdriver. All connections are good, RAM connections are good. Here any burnt? There is no mark. Battery area, RAM section. Yeah. See, before giving power supply, first step is we need to observe the motherboard. Okay. Next step is giving the power supply. First we will check giving the supply the main voltages. Main voltages in the sense, first we will check two major supplies. One is RTC is good or not, and second thing is two CLRs. Two CLRs in the sense, one is AC supply CLR. This is the one PR901. Okay, this one is from AC side and this one is from battery side. It's a 917 PR. See, the main thing is, especially in NVDC technology, see this ISL IC is there, no, charging IC, 88938H something is there. So this one is NVDC technology. In this case, especially you need to give the more concentration on battery side CLR because it will work through the battery side CLR. Okay, so in maximum number of laptops motherboard we are using the AC side CLR. Okay, especially in NVDC technology battery side. Okay, two CLRs we need to check first, and before that RTC is good or not, that we will check using the DSO because it's an advanced level, right? So that's why I'm using DSO. See, first without giving power supply I will check the RTC section. Here is the RTC diode. It's a PD3. PD3 is the RTC diode. The supply will come or not. See the output. Yes, it's coming 3 volts. See, here is the maximum 3 volts. There it's moving. There is no fluctuation in the waveform. So RTC section is good. It directly in this particular motherboard directly goes to PCH. That's why I'm checking only this area. Second thing is we need to give the power supply. After giving the power supply, what will be the voltage? We'll check in CLR. Okay, first AC CLR we will check, then we'll come to battery CLR. Now I'm giving the connection. I gave. Carefully you need to check. The thing is here AC CLR. See, here voltage I need to increase, then only it will show 19 volts or what are the voltages. See, 19.5 volts we are getting, right? 19.5 volts we are getting. Okay, this one is AC CLR, then it's a good. Okay, now we will check battery side CLR. Battery side CLR using DSO. Now here is the battery side CLR. See, battery side CLR maximum 13 volts. This is also good. This is the first part. See, the level of the signal also straight, it's a pure DC. Okay, first we need to check these particular basic voltages, then we come to know the step down voltages are good or not. Once main power supply is good, then here is the jumper PJP 100. Here we will get the battery side voltages. It means 12 volts or 16 volts or 17 volts, what are the battery CLR voltage we will give, that voltage we will receive here. It means it's a 12.5 volts we will receive first point. Second point is once this IC, that PU100 IC receives the main supply, immediately it will release the LDO voltages. LDO voltage will release pin number 16 and 17. Using this capacitor we can check. This is the LDO. Okay. After that, here is the coil. Coil output is the 3 volts always. Okay, 3 volts always is the output coil. And one more thing is here pin number 9 is the power good. Power good where we can check here resistor is there here pin number 9. So here we can check the voltages. So total how many? It's a PJP, it's a jumper 1, it's a input section and LDO section, and next 3 volts always, it's input and output both side we need to check, and next the final output is power good. Okay, so now I'll give the supply, we can check the possibilities, what are the voltages will come. So directly you can check. I'll give the power supply. See, I'm going to give. So first the thing is input is correct or not. You can check also waveforms, because waveform is very important. See here 13 voltage 12.5 volts we are getting. It means input supply is good. If supply is good, then only the 3 volts always will work, otherwise it won't work. Okay, now LDO I am checking by this capacitor. See, capacitor voltage is 3.0 and 4. Okay, 3.5 to 4. It's LDO is good. Next, this is the coil output. See, here is the coil output. One side the signal, how it looks. See, if you reduce the time, it will come like this. This is the signal. Okay, in DSO you check, this is the one side will get like this. Okay, in other side, see the maximum is 12 volts. 12 volts is coming inside. Okay, means high low MOSFET will be there. No, that is functioning inside. So here is the input is not 19.5 volts. Here is actually 12.5 volts. So that's vary. Next is output. This is the always 3.5 volts. 3 to 3.5 volts means it's a 3.3 volts we are getting. It means output always also good, LDO also good, and input voltage 12.5 volts, that also good. You see, one more time, 12.5 volts. Now the thing is, if all is good, then only this IC will release the power good. Power good, which one? Here is the that resistor. Here I am checking 3.5, 3.0. It means this IC releasing the power good. It means it's completely 3 volt section is good. In case 3 volts we are getting always, but 3 volts power good is not generating, then it's a problem with the IC. Okay, now this section is good. There is no doubt about it. We'll check other section. Before this, what are the signals? That also we have to count it, right? So the main signal is, see, once the supply is good, means 12.5 volts is good, then IO will release always on signal. Which one? ALW on signal. IO will release. Okay. Once supply is good, supply will release the enable signal to the 3.3 volts and 5 volts IC. So there are two enable signals. One is from the supply, second one is from the IO. IO always on. Total two enable signal will come to 3.3 volts, and there are three output. One is LDO, second one is 3 volts always, third one is power good. Here 3 section is good. Next we will check 5 volt section. Now we can see the 5 volts IC section. Here is the jumper. From jumper input, this IC will receive the input from this particular PJP101 jumper. After receiving, immediately this IC will generate 5 volts LDO. Okay, 5 volts LDO. When it will generate, immediately once it receives the input voltages, it's a 12.5 volts. So the LDO voltage where we have to check, is the pin number 15. Is that pin number 15? It's 5, 10, 15. Here is the capacitor. Here we can check the LDO voltage. Okay. Once this IC receives the input, LDO voltage will generate. After that, two enable signal will enter to this particular IC. One is from supply, other one is from IO. IO always on, and supply voltage divider, two enable signal will enter. Once these two enable is good, then IC will produce, generate 5 volts always. Okay, 5 volts always. Once 5 volts always is good, then the power good signal will come out from here. Okay, pin number 9. So total how many signals? 2 enable signals, 1 power good signal, total 3 signals, and voltages, 1 input signal, 1 input voltage, and LDO second one, third one is 5 volts always. So now I'm going to give the supply, then we will check the supply path, input path here, and here in this capacitor we will check the LDO voltages, and output voltage, anyway coil is there, coil we will check. So otherwise directly pin number 20 and 19, it's a 5, 10, 15, 20. Here we can check in this capacitor is given here, so here we can check. Okay, so now I'm giving the supply is here. So in advanced level, DSO level, we need to check. So now the supply, input supply is good, 12.5. Okay, 12.5 input is good. Then LDO from this capacitor is good. There is no fluctuation in the waveform. Good. Next, the supply, the main 5 volts. Yes. Here it's showing 8.0 volts because it's a input side. If we check the coil output side, then we come to know so exact signal. See, one side, this is the input side. So output will check. And what about this? Is this 5 volts? No. Okay. Anyway, that side we will check. So now, if input voltage is good, 5 volts always is good, then the power good out will generate through this resistor. See, the 5 volts maximum. Once power good is good, then 5 volts also will be good. So the power good is 5 volts. This side. Okay, this is the power good. See, the most of the technician will do these mistakes. So what is that? After checking 3 volts and 5 volts always, they won't check other related voltages. What will be the voltages are present in S5 state? Those things we need to check. See, once 3 volts and 5 volts will generate, after that immediately SIO, what is that? SLP sus ash signal will release. Okay, from IO, SLP sus related voltages, signal will release. Then what will happen? You will you will get the PCH voltages. PCH related voltages means 3.3 volts always PCH. Okay, see here the PJP38 jumper is here. So the PJP38, this UZ3 IC will convert 3 volts always to 3 volts always PCH here. So we need to check this one. Once these supplies are good, the power good also is good, then the IO will release sus voltages, signal. That signal will come through this IC. Once IC is good and the signal also is good, then this IC will release PCH always, 3.3 volts always PCH. After that only the PCH is good or not, that we can consider. See, now I have given the supply. Let me check in this particular point. See the DSO, we are getting 3.3. It's a PCH voltages. Okay, the PCH 3.3 volts always PCH voltages we are getting. It means we are getting the SLP sus related voltages, and one more PCH always on signal from IO. Okay, now what next we have to check? Once the PCH is good, next we have to check the prime voltages, because we already get 3.3 volts always. Now in S5 stage, prime, PCH 3 volts and 5 volts always, and the power supply. These all should be okay. Okay. Now it's a prime related. Prime, what are those? 1.8 volts, 1 volts prime and 1 volts prime core. 3 are there. So one by one we will check. First we will check 1.8. See, here we are checking 1.8 volts primary voltages. See, here is the input PJP 501. Actually, the input will be 3.3 volts for particular section primary voltages. 1.8 volts receives the 3.3 volts input. Okay, here 6 leg IC is there. It's a PU 501. It receives enable signal in pin number 1. What is that? SLP SIO sus. Next, finally, it will release the output voltage in pin number 3. Okay, the pin number 1 is the enable, pin number 3 is the output. But what about input? Input is pin number 6. Here is the 6. Okay, so now the input voltage is 3.3 volts. Input here 6. Pin number 1 is enable, pin number 3. What is that? Pin number 3 will be the output. This coil is output. So here we need to check what the output. See, here it's a very less voltage it will take, no? So that's why the only one inductor coil is used, not big one. Okay, so now I'm going to give the supply. Let us check what voltage and what signal we are getting. Here is the input, the 3.3 volts we are getting, right? See, 3.3 volts. Now the output directly I'll check the coil. See, coil one side is signal like this. I'll reduce the time. See, signal is like this, and output signal we will check. Output is 1.8 volts. See, the coil always oppose the AC and allows the DC. The pure DC voltage is 1.8 volts. Okay, now you got it. The output of the coil is 1.8 volts. Now it's a clear. See, it's a good sine wave we are getting. I mean, not sine wave. It's a DC pure straight line we are getting. So we got 1.8 also. There is no issue with this. Next we will check 1 volts prime. Here PU301 is the 1 volts prime IC. It's a output coil. It's a PL301. Okay, it receives enable signals. Actually, first input signal, I mean input voltage, what is that? 12.5 volts it receives, and enable signals SLP SIO sus. Once enable will come to this IC, then it will produce, what is that? 1.8 volts. Okay, this is the input and this is the output side, and output junction is PJP302, this one. Okay, now we will check. I am giving the supply. Till now 1.8 we got. This is a 1.0 prime. Now the supply. See the DSO. DSO supply is maximum 3 showing, but if I increase 12.5 it's showing. Okay, now I will check the coil input directly. Yes, it's generating. If I reduce, so this is the input. Okay, input signal is coming 12.5, 501. What is that? Is varying. Okay, usually 12.5 should come. Next, the output. Here I'll check 1 volts, 500, 1 volts. It's varying. It's a varying. Output I'll check. Guys, something. See, voltage is varying. 500, 1 volt, 500, 1 volt, 750. 1 minute. I'll make it auto. See, here it's a waveform. So 1 volts prime, but by default it's a waveform or volts. Pure volts should be there in output section, but we are getting waveform. Okay, now multimeter I'll check what will be the voltage, then we'll confirm this could be the reason. See the supply here 7 volts we are getting, guys. Here is the problem. Actually it's a big problem only, not a small, because it should be 1 volts. Here voltage getting dropped because of AC voltages. Now I'll check the AC in DSO. See the waveform. Here is the problem. It's 100% we got. The main problem is here, means it's not properly rectifying. For this, what we have to do is, first we need to remove this jumper, and we need to check again we are getting 1 volts or not. In case we are not getting 1 volts, then IC may be the problem or some capacitors may be the problem. That may give final decision to your troubleshooting. Okay, till now we checked all voltages were good and it was very straight line and exact or maximum more than that voltage we are getting, but here we are getting less than 1 volts. In DSO also it was varying, right? So what it was varying, it's 1 volt, 750 or 500, like that it was varying. But the thing is, it should not vary that much. So in case of highest it's okay, but it was very less. So now we are getting the voltage. Let's see the sign, AC signal is coming here. It's not purify is not happening here. So this could be the problem. Okay, guys, this may doing the malfunction to on the signal, because continuously it's varying. In case if it is varying, it won't understand properly, and exact voltage it required 1 volts, but lesser than that volts, obviously it will be in abnormal state. Okay, that could be the reason. Here we found the exact reason. After that also you may get, but the thing is the main reason here. First we need to rectify, then only we can go ahead. Okay, that's it, guys. This is how we have to check in advanced level troubleshooting. Okay.